In the 1967 film The Graduate, a college student, reluctantly approaching adulthood, was offered some prescient career advice.
I just want to say one word to you. Just one word.
Yes, sir.
Are you listening?
Yes, I am.
Plastics.
Exactly how do you mean?
There's a great future in plastics.
He was right. In the 1950s and 60s, the plastics industry not only transformed manufacturing around the world, it fundamentally altered the way people use and dispose of everyday products. Most plastic products are made from petrochemicals and are durable, lightweight, water-resistant, and inexpensive to produce. Worldwide, an estimated 330 million tons of plastic will be manufactured in 2010. That's more than 100 pounds of new plastic for every man, woman, and child on Earth. But in the United States, only 7% of plastic is recycled. Much of the rest ends up in landfills, where it could remain for more than 1,000 years. Other plastic is carelessly discarded, and it goes from stores to storm drains, streets to streams, eventually floating out to sea. The currents that run along the California coast converge with 4 other prevailing currents from the far reaches of the Pacific Ocean. When they meet about 1,000 miles off the coast of California, they create a slow, swirling vortex known as the North Pacific Gyre. Today, the Pacific Gyre is often referred to as the Great Pacific Garbage Patch. With most of the plastic broken into tiny pieces, the garbage patch can't be seen from the air. Much of the debris floats a few feet below the surface. Mary Crowley charters yachts out of Sausalito, California, and has spent nearly 40 years on the open ocean. After first learning about the garbage patch, she knew which direction to point her ship.
Mid-ocean is kind of a beautifully unique area. You know, could be 1,800 feet, 2,000 feet deep. It's this beautiful blue, and then you look closer and you see this confetti-like plastic.
In August 2009, Crowley spearheaded a month-long scientific expedition to study the debris. The 151-foot Kaisei, whose name means ocean planet in Japanese, was joined by a second research vessel from the Scripps Institution of Oceanography in San Diego.
When we got out into the Gyre, we began doing bow watch, where we would record how many pieces of plastic the persons could count in half an hour. There were areas where we would see 300 to 400 pieces in half an hour.
Things in there right now. Might as well get them in there.
Marine biologist Margie Gassell works with the California Department of Toxic Substances Control, a state agency that regulates hazardous waste. Her specialty is the impact of contaminants on fish, but she wasn't ready for the impact the expedition would have on her.
The thing that was most shocking to us that we really didn't expect was all of the tiny fragments of broken down plastic. Every one of our samples had these plastic fragments in them, whether we were 200 miles from shore or 1,500 miles from shore.
Although petroleum-based plastic polymers never completely dissolve, over time, sunlight and wave action cause the plastic particles to break down. And because they are so widely dispersed, the billions of tiny plastic fragments in the ocean will be nearly impossible to clean up.
The amount of debris that we collected was pretty staggering. It was very depressing and very disturbing.
I don't like the jellyfish eating the plastic at all. That is going to cause our ecosystem real problems.
We brought back over 300 fishes, particularly the lanternfish. We think that they're an important link in the food web. If they are in fact picking up contaminants, then those could be passed to the fish that consume them and potentially to humans.
The samples from Project Kaisei's maiden voyage are tested by the California Department of Toxic Substances Control. The samples are run through a mass spectrometer. It removes and separates toxic chemicals for analysis, such as PCBs and BPA, or bisphenol A, which are found in plastic and are known to be harmful to marine life and humans. As research is being done to analyze the problem, the search for alternatives is in the works.
So the plan is we're going to bring in methane.
At Stanford University, promising research is underway to develop an eco-friendly process for producing bioplastics that are benign by design. Meanwhile, Bay Area cities are also taking action. San Francisco and San Jose have banned plastic shopping bags, and state regulators in 2009 passed new rules that require all Bay Area cities to do more to reduce trash going into the bay. Still, the size of the challenge is daunting, and any solution involves all of us.